What you see here is the wireless connector, and the heart of the wireless connector is in fact this chamber, the reverberation chamber. But outside there will be external instruments, and these instruments can be like a spectrum analyzer, a network analyzer, and also an oscilloscope. And the choice depends a little bit upon the type of applications that you want to do. At first, let's have a look what's inside this chamber. So for the moment, we have been putting in one device under test, which is a phased array device, which is being fed by some bias and some USB control. So there is no RF going in here, just the state is being controlled by the USB. And then here, there is the phased array architecture that allows us to transmit and to receive with the device under test. This is a commercial available phased array system. We can put this device in the chamber at almost any location. And that's very handy, of course, because you don't have to worry about alignments in contrast to, for example, the anechoic chamber. Now, what's important though is that the direction of the radiated fields is upwards to the ceiling of the chamber. Why? Well, we want to avoid direct reflection to that device under test. And the top of the chamber has been designed specifically to minimize the possibility to get a direct reflection. And in fact, between a steering angle of -60 to 60, that direct reflection should be avoided. So that's a kind of an important thing to take into account. Now, how are we bringing in the DC and how are we bringing in the USB control or any other type of control? Well, on the side of the chamber, there are panels. And I do have an example here of a panel. And you can see here the outside. For example, here you have some waveguide. If I open this, you have a USB connection of this panel. There are coax connections, BNC connections and coax connections. So you can feed in RF into the chamber, or you can basically measure the fields inside the chamber by bringing the RF outside. So there is a lot of flexibility in the configuration of this panel. So we have one of these on the side of the chamber. Now, the device is radiating or receiving fields. Now, you need, of course, something that is either measuring the fields or generating the fields. Well, on the side also, we do have reference antennas. And these antennas are being provided with the system, and depending upon the frequency bands that you want to measure, they will be different. And they're coming out on the side panel. And here you have an example of such a panel. So in this chamber, in fact, we do have these two types of antennas. And on the side, you basically have a waveguide and you have an RF connection. So this allows us then to connect the external equipment. And you can see here we have been connecting a Rodian Schwarz spectrum analyzer as the receiver, because we will be using the device in this case for radiation and not for receiving. Now, besides that, we also have stirrers in the chamber. Why? Because this is a metallic chamber, so we will have standing waves. And we want to create actually a uniform field in the chamber by doing some averaging techniques. And to create that uniform field, you need to stir these waves around. And for that, there is a vertical stirrer, and at the top, there is a horizontal stirrer. And they can be used in two modes. They can either continuously stir, and we can do some sampling of these fields and process them, or we can actually step the stirrers and per step measure the fields and then process them later. Now, when you are going to measure with a spectrum analyzer, you also need to do a additional calibration. Why? Because the device under test by itself, even when it's not active, is going to change the loss properties of that chamber. And to characterize that, there is a calibration module foreseen in the chamber on top that allows us to measure the difference between factory cal and, in fact, when you are putting in that device under test while it's inactive. As soon as that calibration is done, at that moment, you also need to take into account the type of antenna you're using as a reference antenna, and you need to take into account the coupling to the spectrum analyzer. So let's come to the outside. So the nice thing of this chamber is that actually it has a computer. And because of the fact that it has a computer, we are able to have a user interface on the system where, in fact, interactively we can do the different types of measurements supported by this chamber. There are different applications supported. For example, power spectrum measurement. We have a FMCW type of measurement for radar applications, and the number of applications will grow in the future. So interactively you can work with the interface. But that's not all. The instrumentation on the site, in fact, is totally invisible. Once you made the connection between the chamber and the instrumentation, you are ready to go, and you only need to use the interface that is being provided over here, and the type of equipment is totally hidden for the user. Now, I can imagine that you also have your own characterization plans and test plans. Maybe you're using MATLAB, maybe you're using Python or something else, and you really would like to integrate the capability of this chamber in these test plans. Well, this is pretty fluently because there is a remote control capability of this system that allows you to easily access the capabilities of the system, set some parameters, do some measurements, and so forth. And the nice thing is, also there, the external equipment is totally hidden for you as a user. So this concludes a little bit the overview of what is the wireless connector and how does it look like and what does it contain.